In this problem, this table gives us information about the number of people present in a local hardware store at time t, and we need to approximate the value of this integral using left-Riemann sum with 3 sub-intervals. So let us draw it first to understand it better. Along the x-axis, time is taken. Along the y-axis, p-values are taken. We draw the points and join them to get the curve. This whole area is divided in 3 sub-intervals. We are going to draw the 3 rectangles over these 3 sub-intervals. The height of each rectangle is given by the y value at the left hand point. So let us look at the first interval. First sub-interval has left hand point as 0. At 0, y value is 0. That means height of this rectangle is 0. For the next sub-interval, the left hand point 7. At 7, the y value is 5. That means height of this rectangle is 5. For the next sub-interval, the y value at left hand point is 23. That means height of this rectangle is, so these are the 3 rectangles. Height of the first rectangle is 0. Height of second rectangle is 5. And height of third rectangle is 23. These are the left hand points. We know that area of a rectangle is width times height. So we find the area of each rectangle and then add them all. Area of the first rectangle is width times height. Width is 7, height is 0. 7 times 0 plus area of second rectangle is 4 times 5. Width times height. And the area of third rectangle is 5 times 23, which is 135. And this gives us the value of definite integral from 0 to 60. But we need to find the value of this expression. We need to divide it by 16. So divide 135 by 16. And we get, this is the approximation of this integral. Next, we need to interpret the meaning of this value. Whenever a definite integral is divided by the width of that interval, then this gives the average value. So we have got that average number of people present in the store during the first 16 minutes is 8.43. For next part, we need to find whether the value 8.43 represent an overestimation or underestimation of this integral. For that, let us look at the graph again. Here we have got the area of these 3 rectangles as 135. But this value doesn't represent the all area under this curve. We have found only this shaded area, but these small parts, these triangles are still left behind. We haven't included those areas. So the answer we have got is an underestimation. So whenever we are going to use left-Riemann sum for an increasing curve to approximate the value of integral, it always gives you an underestimation because some parts under the curve are still left behind. They are not included. So it always gives you an underestimation. Now let us see what happens when we use right Riemann sum for an increasing curve. So using the same information, let's draw the graph. Let's write the width of each interval. It's 7. Width of second interval is 4. Now we are going to use the right endpoints to get the height of each rectangle. First subinterval is 0 to 7. The y value at the right endpoint is 5. That means the height of this rectangle is going to be 5. Now we are going to draw the rectangles using the right endpoints. That means height of each rectangle is decided by the y value at right endpoint. The y value at 11 is 23. That means height of this rectangle is 23. And the height of third rectangle is 37. And we use the same area formula. Width times height. The area of first rectangle is 7 times 5 plus area of second rectangle is 4 times 23 plus area of third rectangle is 5 times 37, and we get the value as and the average value of integral would be, to find the average value of integral, we divide this value by 16 to get 19.5. That means average number of people in the store during 16 minutes is 19.5 using the right endpoints. So we can see that using the right endpoints, the answer has been increased. Now let us see whether this is an underestimate or overestimate. Here, while calculating the area of these rectangles, we have calculated some extra area as well. This extra area. That means this is an overestimation. That means the right Riemann sum will give you a value greater than the actual area. Using the right Riemann sum for an increasing curve always give you an overestimation. Here we can see that left Riemann sum for an increasing curve gives you an underestimation, whereas a right Riemann sum for an increasing curve gives you an overestimation.